I work on the VisIt project. This presentation and the paper are really a joint effort with Krishnan at Lawrence Berkeley Lab. He's doing a lot of the cool custom UI stuff and re-architecting for that. Unfortunately, he couldn't make it here. Hopefully, we'll drag him here next year. I think he would really enjoy this conference. As he said, I'm going to be talking about Python's role in VisIt. Well, that means that you need to know what VisIt is, of course. So how many people actually know or have heard of VisIt? All right, so a good spattering of people. That's good. So what does VisIt do? Well, it's an open source, parallel data analysis and visualization tool for mesh-based data. So your large HPC, grid codes that write out unstructured meshes or structured, rectilinear meshes with scalars, tensors, vectors, oh my, that type of thing. That's what VisIt was designed to do. So VisIt was started at Lawrence Livermore National Laboratory around the year 2000, and so it's a pretty mature product at this point. The original versions went out around 2002, 2003 to Livermore users, and then over the years we've grown as part of the broader research community and visualization, and we're a full open source project now, so we have a BSD style open source license. So I got to give you lots of pictures since this is the visualization track, so we'll tell you what some of them are. So this guy here is a hero run from several years ago at this time of a Raleigh-Taylor fluid mix simulation. It's kind of a famous, pretty picture with two fluids mixing, heavy and light mixing. There's an initial interface, perturbation, then under gravity they mix and they go for fully turbulent. And this is a really high fidelity DNS simulation. And what you're seeing here is really, the original data set was a 3K cubed rectilinear grid with a whole bunch of scalars on it. And for this picture here, what we've done is we've basically extracted the subvolume that's the mixing layer, so where all the fun stuff's happening. And this is just a plot showing you the different levels of density on that. All right, I'll try not to do that again. I'm very sorry. Are we all back? Are we okay? No one needs emergency medical help after that, do you? So here's some more pretty pictures. So what kind of things can you do with VisIt? We have a really cool streamline capability. All this stuff works in parallel. So VisIt runs on your desktop, but it also runs on supercomputers. So streamlines on, in parallel across the machine is a pretty difficult problem, and there's been a lot of research going into that, and it's been productized in VisIt. Of course, we have vector and tensor glyphs. I already showed you a pseudo color plot rendering. We also have a really cool scalable volume rendering that can go up to giant mesh sizes. We have some molecular visualization capabilities, and we have a teeny bit of kind of info visualization, such as like a parallel coordinates plot. If you're not familiar with that, it allows you to view several scalars and look at correlations. And in VisIt, you can do some fun things like grab parts of the bends and use that to drive another plot, etc. But VisIt really, we kind of joke that it's pretty poorly named. So why is that? Well, there's two reasons. So if you hadn't heard of VisIt before and you immediately went to Google and you typed in VisIt, you are going to probably get an advertisement to come next week to London for the Olympics. You're not going to get VisIt, the visualization tool, right? So unless Google knows way too much about you, and then you might get VisIt. It says you're a scientist, and so be careful. But so that's one reason why VisIt's a pretty poor name. But the other reason is it's way more than just pictures. So we do a lot of analysis and post-processing with VisIt. Since it reads all of our codes, and it reads over basically 100 different types of file formats, from standardized ones to random guy, random guy down the hall does a hack. It's used as a platform for doing a lot of stuff. So what kind of stuff do people do with VisIt besides just make pictures? Well, data exploration is important. So getting into your data, animating it as a scientist, having the right tools to basically zoom in, figure out what you want to do, watch things animate over time. Of course, you need to do that with a visualization tool. But quantitative analysis is very important too. So say you have a material region and you want to integrate density times volume and give you the mass of a particular material, etc. These are the type of primitives that VisIt has to allow you to do that. You can do summary queries. You can also extract curves over time, find out how things evolve. So you can get numbers back out of VisIt, not just pictures. This is a really important use case at Livermore, especially with large-scale HPC codes. You have your mesh and it's run along fine, and say you're a Lagrangian code and it just starts twisting up or bow tying on you. Well, the simulation's eventually going to crash. Things are going bad. you don't want to open up a debugger on 2,000 processors and try to connect and try to figure out what's going wrong or whatever. You want to look, a scientist especially, maybe a code developer could do that, but a scientist especially wants to try to figure out what's going on and rewind time and fix things. So they'll pull up VisIt and look in their data and write some expressions that see where things are going numerically unstable, et cetera, and pinpoint things. So another use case is comparative analysis. Of course, there's the view graph norm, which you hear, and you squint, and you look, and you say, okay, those are good or those are bad. Of course, we support that, I will say, but we have some more interesting things. So we have the ability to take your meshes and map them onto each other in parallel, so you can do differencing, and you can get more quantitative with that. And then, again, we are a Viz tool, so an important use case is presentation graphics. Communicating results is very important. So making movies, doing stuff like that, we, of course, support that. So we're almost to the Python part. Got to give you a little bit of motivation. So what does VisIt look like? So we're client server, parallelized client server architecture. Really, you can break it down to local and remote. And remote doesn't have to be, the top 100 supercomputer in the world or whatever. It could be on your desktop as well. But things are broken down into a viewer, which is really a state manager. So that kind of coordinates everything. It also contains the visualization windows that you see for rendering. And we have several clients. So VisIt's GUI, which provides some widgets as a client. We have a Python command line interface, which I'll talk about. You can just import it into Python as well. And there's Java clients, et cetera. So that's kind of the local component. And where all the heavy lifting is done is in the parallel component. Parallel cluster. We're a C++ code, at our core, everywhere. And we use MPI, standard, standard distributed memory parallel scaling code for today's, HPC clusters. So we use data flow networks. It's kind of similar if you've seen other tools like this, like ParaView and et cetera. These are similar architectures. Where does Python fit in? Okay, so Python, you can think about the way we use it in two different modalities. So the first is the Python client interface, which gives us state control. So that allows you to go in and set up plots how you could with the GUI, scripting basically, and you can wield all the building blocks and you can connect them all together and you can figure out, okay, hey, here's what I want to do. And the other use case is basically low-level processing. So we have a Python Filter Runtime, and this is not as mature as the interface. It's actually only a few years old. That allows you to do some direct mesh manipulation on the parallel cluster, and get your results back. So our Python client interface, it's worthwhile to say, has been around for quite a while, and it's one of the reasons why VisIt is such a solid tool. And VisIt's a pretty big project. It's not my baby. It's an effort of many people. I would say Brad Whitlock and Lawrence Livermore, he was kind of the mastermind of the CLI and the force behind that made that work. And so the CLI is very mature. It's been around for a while. There's tons of documentation on it. You can go out on the web as long as you aren't visiting London instead of VisIt. And you can get some information on that. So for this talk, I want to talk about three things. The first two are really state control. So what does our Python client interface look like? And what have we been doing to support custom Python UIs? And so those are both command and control type of things. And then I also want to talk about the Python Filter Runtime. So Python client interface. So during the IPython notebook tutorial, I got really motivated. I said, well, what a way to spectacularly fail during my project. Let's try to import VisIt in there, right? So let's see if it works. But so what I want to do is I want to give you a basic, you can probably see that. So there's some magic we have to do to get VisIt imported. If you're interested in why all that's necessary, I could talk to you about that online. But anyways, what we want to do is I want to introduce you to basically, make sure it popped up. Yes, it's there. Basically, the 5 building blocks that VisIt uses to do everything. So the first is the database, so how you get your data. Second's a plot, what you see on the screen. So that's kind of at the very end of your output, how you're going to render things to the screen. The third is an operator, which allows you to manipulate your mesh somehow. It might be slicing. It might be an ISO contour, ISO surface, et cetera. The next is a query, which is really a data summarization operation. And I'm going to go through all these as we do this, but it's take big numbers, turn them into small numbers, get a small number back type of operations. And the last one is VisIt's expression language. So if you have a mesh with density on it and you want to calculate mass, You could create expressions that give you derived quantities based on what exists in your files. So in this example, I'm going to create 2 plots for you. And the first one's going to be kind of a pseudo-color plot of 3 slices of this field. And then the second one is actually going to be a streamline trace of the gradient of this field. So if you look here, I mean, it's pretty compact code. So I'm opening a database, creating a plot here, add the operator, which is going to modify the plot. So we have these 3 backplanes. Just to make sure I can demonstrate everything, I'm going to find out with the query, hey, what's the maximum value of this field? And here, I don't have the gradient in my data set, but I want to take it on the fly, have VisIt compute it for me. So I define an expression that gives me a vector field for a gradient. And finally, with that vector field, I do some pretty plotting with a streamline plot. So run this guy here, and VisIt's hanging out in the background, and here you are. So this is the plot that I just set up with that code. And so this gives you kind of idea of the high-level control you can have with VisIt's client interface. Since I said I got excited about IPython Notebook, I figured, well, we should be able to, grab some VisIt pictures and have them pop up in here. So, that's about 4 lines of code with pretty high impact, so it's pretty fun. So there's that. One other thing I want to talk about while I have VisIt up and running here is that a good way to learn the Python client interface is we have a macro recording capability. So if I wanted to come in here and I said, I really don't want my slice to be there, I want it to be elsewhere, I can go to this controls and command, and I can record. Of course, there's the answer right there, but I can record what I do in the GUI and have it spit out Python. So apply that. You can see that the slice plane changed, and I'm going to go ahead and stop. OK. So this gives me the Python that I can then put in my script. So that allows you to really go through things rapidly. OK, so I'm going to gloss over this a little bit. So this is just kind of nuts and bolts how you get up and running. So I imported it into Python VisIt, but VisIt comes, kind of batteries included with its own binary that gives you a Python interface. That's the typical way that it's used. You can run things off screen, coordinate big parallel rendering, et cetera. And we do a lot of analysis by scripting VisIt in this way. So it's a really powerful tool. So, but I do want to go forward and talk to you about some new things we've been doing over the last few years. So first is custom Python UIs. So, and Krishnan at LBL, he's been the guy who's making a lot of this happen. We use Qt for our current GUI, and our viewer itself, even though it's just basically a render window, has Qt widgets in it as well. And because of that, we chose PySide for an LGPL Python Qt wrapper, and that's kind of at the core of our system. So what can you do? Well, you can steal VisIt's render windows and throw them into your own applications. In certain circumstances, you can steal VisIt's UI widgets that already exist and throw those into your applications. And you coordinate everything with this same Python client API that's been around forever and has a lot of capability. So another advantage, obviously, is if you want to do custom GUI development, you don't always want to be coding it. You can use Qt's UI designer, and that'll get you pretty far for doing a custom client. So why would we do custom clients to begin with? Well, VisIt is a very general purpose tool. And obviously, there's people in certain scientific domains that they know they want the same 3 plots every time, and they want it now, and they don't want VisIt to get in their way. So that's what this is kind of targeting. You might say, well, great, OK, VisIt's got PySide now. That's fine. They built PySide. They did some cool stuff. It required a little bit more than that, because VisIt's client process and its viewer process, they were originally all separate applications, and they all talked over sockets, and they're all threaded to do all kinds of stuff. So we had to make sure that these guys could all live together in order for you to be able to steal the render windows, steal the GUI widgets, all that stuff. So it actually did require a little bit of re-architecting of VisIt to make it happen. All right. So let me show you a quick example here of just a very brain dead, let's see. So this time I'm going to use the CLI. And just give you kind of a brain dead example of us stealing VisIt. So you can notice that VisIt's window popped up in the back. Keep wanting to hit Shift Enter when I'm when I'm there. So where are we? Okay, yeah, so here it is. This is the little toy example, which has an ISO surface. You can't see much now, but it just set up a couple widgets with Qt and said, hey, I want to sweep between a couple values and, just feed those events in to update the visit interface. So that's an example, a toy example, and the code's going to be with the paper if you want to play with that. That's kind of, for the purposes, made something pretty small and compact. Now, what are we really using this kind of stuff for? So this is Hari's work. So again, you have domain scientists that they don't want to do everything in VisIt. They want to do a lot of things in VisIt really well and really fast. So one example of that is supporting global cloud resolving model. So in this instance, there's specialized lat-long plots, different types of zonal averages that they want to do for their analysis. And we wanted to bring that just kind of to the front. 4 minutes? Okay, great, good. So what we did is we used the Python interface, custom UI skins. Here we are. So we can do these custom applications. Same application, different skin, brings different plots to bear. So that's an example of how we're using this. And so that was kind of a targeted example. This is still climate related, but this is a little different. So UV-CDAT is I would say it's kind of like this mega tool that they're creating where they're trying to combine all the Viz packages out there and bring them to bear for climate scientists. And so Python's in charge of this whole thing. This is actually not PySide, it's PyQt, but things are very similar. But what they're trying to do is bring all these plotting packages together into one thing, and it's pretty wild. So they're doing it. VisIt's in there, ParaView's in there, a whole bunch of other things are in there. And they have this mega application, and they can just get all these crazy plots from all the tools and really roll out functionality quickly. All right, so rounding the end here, Python Filter Runtime. So just like VisIt has lots of building blocks that are readily usable, but it might not be applicable to your purpose with the GUI side or whatever. Everyone wants low-level data analysis. Low-level, I want to touch my zones on my mesh, basically. I want to do things. So to address that, we embedded Python interpreters in our MPI processes. We use VTK at the low level, so we were able to use the Python wrapper modules there to get access to the arrays. And that's nice because we can also get NumPy and SciPy, et cetera. So it's pretty cool. One point of criticism I'll probably face is I have my own stupid MPI wrapper, which I will replace in the future. But it's called MPI-com. It's just a very simple thing that we use to coordinate these filters. And right now, you can't do everything with this, but you can do expressions, which are derived quantities, or summarization operations. And let's see here. Let me just do this example real quick. If my computer doesn't explode itself. Okay. So I'm just going to run this guy. Actually, well, I do have, I think, enough time. So this is what the filter looks like. It inherits from something that looks close to our C++ class. We're not completely happy with this interface. I think we could make it a lot more Pythonic, but it does everything that our C++ can do. So do things in parallel. You can see here after I'm done processing all the chunks of my data set, I do some simple things. This guy just takes a cell average. It's pretty simple. And let me just run it. So I'm gonna run this from the Python client interface. Call it. Okay, so I get an average value. Then, just to convince you it actually works in parallel. Okay, I close my engine. I open up a parallel engine with 8 processors. I got the same. I got the same result. Fantastic. And just another thing to sort of convince you. Which one's which? Nah, this one. So I create a little expression that tells me which processor my mesh lives on. So that's just me proving that I've done it actually in parallel. So that's a pretty simple example, and I'm about to get kicked off here, but I'm just going to very briefly cover another example. So what are we really using this for? We use our expression, our Python expressions to drop a whole new expression framework into VisIt with an OpenCL backend. So our expressions are kind of like a domain-specific language. They're very simple. This is an eye chart, but this is a Q criterion, so which is a vortex detection metric, and we put that into Python and did this all in Python and used PyOpenCL. Took all these operations from the user, compiled them into one kernel, shipped them off, and got some big speed ups on it, even over our C++ implementation. So this is some pretty cool work, and it's all done using Python. And I would like to say PyOpenCL is like one of the greatest packages ever. So I don't know if Andreas is here, but a lot of people are allergic to OpenCL in the C world. They say, oh, geez, there's pages and pages of code that you have to do to get. PyOpenCL is awesome. You can get up and running really quickly. So, we put all this Python glue together. We dropped it into VisIt. We ran it on, on 256 GPUs across a bunch of nodes. Everything worked, and we got speed up. So it was really cool stuff. All right, so sorry for running over. Hopefully we have a little bit of time for questions. All right.
So I had a question about your querying. Are you querying based off of the data in BTK, or that you munched to BTK from the original format, or are you querying the original data?
It depends. You can do both. Okay. So there's it's a little strange, but you can query at the beginning or the end of the pipeline.
Okay.
So.